America is building solar farms faster than it can build the factories behind them. That is the uncomfortable reality behind the clean energy boom. Across the United States, solar panels are spreading across deserts, farmland, rooftops, industrial parks, military bases, and utility-scale projects from Texas to California. Solar is no longer a niche climate technology. It is becoming part of America's electricity system, data center economy, manufacturing strategy, and national security debate. But behind every new solar project is a question Washington still has not fully answered. Who actually builds the technology behind the transition? Because the uncomfortable truth is this: America wants a solar boom. But China built the factory system that makes that boom possible. China did not dominate solar by accident. It built the supply chains. It scaled the factories, it trained the workforce, it drove down costs. It created industrial clusters where raw materials, machines, components, engineers, and logistics all reinforce each other. And that changed the global energy race. For American solar developers, China's scale created cheaper panels and faster deployment. For American manufacturers, it created a brutal competitive problem. For Washington, it exposed something deeper. The United States can install clean energy technology faster than it can manufacture the industrial base behind it. That is the real factory problem. Not whether America can build a solar panel, but whether America can build the full ecosystem behind the panel. From polysilicon and wafers to cells, modules, inverters, grid hardware, and the skilled industrial workforce needed to make all of it at scale. And in 2026, this question matters far beyond solar, because the same pattern is showing up across the entire energy transition: batteries, transformers, electrolyzers, power electronics, and grid equipment. The country that controls the factories does not just control jobs, it controls pricing, supply, leverage, and speed. So the real question is not just whether America can deploy more solar, the real question is whether America will build the industrial power behind the next energy era, or simply buy it from someone else. For the United States, this is not just a clean energy issue. It is an industrial strategy issue. Solar is now tied to almost every major pressure point in the American economy. Electricity demand is rising because of data centers, artificial intelligence, electrified factories, electric vehicles, heat pumps, and a more power-hungry digital economy. Utilities need new generation, states want lower electricity costs, companies want cleaner supply chains. The military wants resilient power, and policymakers want jobs in the industries that will define the next several decades. Solar fits perfectly into that story because it can be built quickly, scaled modularly, and deployed in many parts of the country. But there is a difference between being good at installing solar and being good at manufacturing solar. The United States has made real progress. Domestic solar module manufacturing capacity has grown significantly, with SEIA reporting that U.S. module manufacturing capacity reached 65.5 gigawatts in 2025, up from 42.5 gigawatts at the end of 2024. But SEIA also notes that actual production remains well below domestic demand. That gap is important because module assembly is only the most visible part of the solar supply chain. A finished solar panel may look simple: glass, cells, frame, wires, and a junction box. But behind that product is a long industrial chain: polysilicon, ingots, wafers, cells, modules, glass, frames, chemicals, silver paste, inverters, trackers, cabling, substations, transformers, and interconnection equipment. So when people say America needs solar manufacturing, the real question is, which part? Because assembling modules is not the same as controlling the full stack. China's advantage is that it built the stack. According to the International Energy Agency, China accounts for around 85% of solar supply chain production capacity and about 95% of PV wafer capacity. That is industrial concentration at a strategic level. It means China does not merely have a few large factories. It has a dense ecosystem where suppliers, equipment makers, managers, engineers, logistics networks, and customers are close enough to move fast and solve problems inside one industrial system. That is the part America is trying to rebuild. And it is much harder than announcing a factory. A factory announcement can happen in a press release. A working factory needs years of execution. It needs reliable equipment, trained workers, stable demand, high utilization rates, quality control, bankable customers, access to materials, and enough scale to compete on cost. This is why the American factory problem is not simply about patriotism or political messaging. It is about manufacturing reality. China's solar boom exposed the fact that America has world-class demand, capital markets, research institutions, and energy developers, but it does not yet have the same depth of solar manufacturing infrastructure. And that is a strategic weakness. Because in energy, the cheapest technology often wins deployment. But the country that builds the technology wins industrial leverage. This creates a difficult conflict for the United States. On one side, cheap Chinese solar helps America build faster. Developers want lower prices. Utilities want affordable power purchase agreements. States want projects completed. Companies want clean electricity. If solar modules are cheaper, more projects pencil out and more capacity gets built. From a deployment perspective, China's solar boom has been extremely valuable. It lowered costs across the world and helped turn solar from an expensive alternative into one of the most competitive power sources in many markets. But from an industrial perspective, the same price collapse creates a major problem. When Chinese factories produce at enormous scale, with deep supplier networks and aggressive pricing, American factories struggle to compete before they have even matured. This is the trap. America wants cheap solar power. But America also wants domestic solar factories. China's solar boom forced those two goals into conflict. If the United States relies heavily on imports, solar deployment can move faster and cheaper. But domestic manufacturing remains weak. If the United States raises tariffs, tightens import rules, or forces more domestic sourcing, it may protect American factories, but projects can become more expensive, slower, or more complicated. That is the policy dilemma. Cheap imports accelerate deployment. Industrial protection supports domestic capacity, but doing both at the same time is difficult. And China keeps raising the pressure. Reuters reported that China's solar exports jumped 60% year-over-year in April 2026, showing how resilient and globally competitive Chinese solar production remains. At the same time, China's solar industry is not operating from a position of pure comfort. The sector is facing record low prices, pressure on margins, and weaker panel sales in some areas. Major Chinese solar companies are also moving aggressively into batteries and energy storage as panel sales become more difficult. That matters because it shows how the competition is evolving. China is not just selling panels anymore. It is moving toward integrated solar plus storage systems. For America, this widens the challenge. Because the race is no longer only about who can make the cheapest panel, it is about who can provide the full clean energy system. Panels, batteries, inverters, controls, grid integration, financing, export packages, and long-term industrial relationships. This is where the issue becomes geopolitical. In the fossil fuel era, power often came from controlling oil fields, gas pipelines, shipping routes, and refineries. In the clean energy era, power increasingly comes from controlling factories, minerals, processing capacity, components, and grid technology. Solar is one of the clearest examples. A country that dominates solar manufacturing can influence global prices, shape supply availability, serve fast-growing markets, and build relationships with countries that need cheap electricity. It can export not just products, but infrastructure dependence. For many countries, cheap Chinese solar is not a problem. It is an opportunity. Faster generation, lower fuel imports, wider electricity access, and less dependence on expensive Western financing. That gives China enormous soft power, not through speeches, but through hardware, modules, batteries, inverters, and project finance. The United States understands this. That is why Washington is trying to rebuild domestic manufacturing, strengthen supply chains with allies, and reduce dependence on concentrated foreign production. But there is a difference between wanting an alternative and building one at scale. Allied supply chains are not created overnight. Factories need orders. Workers need training. Suppliers need confidence. Investors need stable policy. And developers need prices that still make projects viable. This is why the solar factory problem is really a test case for American industrial strategy. Can the United States move from policy announcement to industrial execution, build enough domestic capacity to matter, and compete with Chinese scale without making clean power too expensive? Can it protect strategic supply chains without slowing down the energy build-out? That is the hard part. Because China's advantage is not just low labor costs. That explanation is too simple. China's advantage is system coordination. It built capacity ahead of demand. It supported manufacturing through industrial policy. It created clusters where companies could scale quickly. It invested in upstream materials and midstream components. It allowed brutal competition inside its own market, which forced firms to get faster and cheaper. And then it exported the result to the world. America's system works differently. The United States has powerful private companies, deep financial markets, strong innovation, and leading universities, but it often struggles with long permitting timelines, fragmented policy, inconsistent incentives, local opposition, grid bottlenecks, and the gap between invention and manufacturing scale. America is very good at creating technology, but it has often allowed manufacturing ecosystems to migrate elsewhere. Solar exposed the cost of that decision. Because once an industry's supply chain has clustered in one country, it is extremely difficult to rebuild somewhere else. You are not only rebuilding factories, you are rebuilding supplier relationships, process knowledge, workforce expertise, and the culture of production. And in solar, production learning matters. Every fraction of a percent in efficiency matters. Every improvement in yield matters. Every reduction in material waste matters. Every increase in factory uptime matters. These are not abstract details. They decide whether a factory survives. So when America talks about reshoring solar, the key question is not whether the first factory can open. The key question is whether the 10th, 20th, and 50th factory can compete. That requires demand certainty, patient capital, industrial skills, upstream investment, and a realistic understanding of what China has already built. But this does not mean America has no path forward. The answer is not to copy China perfectly. The answer is selective resilience. America does not need to manufacture every solar panel used in every project, but it does need enough domestic and allied capacity to avoid strategic dependence. It needs domestic capacity in key components, secure sources of materials, manufacturing incentives that last long enough for companies to invest seriously, and permitting reform so factories and energy projects are not trapped in endless delays. It also needs grid expansion, because solar panels are useless if projects cannot connect. And it needs to treat clean energy manufacturing as part of national industrial strength, not just climate policy. That distinction matters, because climate policy asks, how do we reduce emissions? Industrial strategy asks, who builds the machines that make reduction possible? Energy security asks, what happens if supply is disrupted? Geopolitics asks, who gains leverage when the world depends on these machines? Solar sits at the intersection of all four. That is why China's solar boom exposed America's factory problems so clearly. It showed that deployment without manufacturing strength can create a new kind of dependence, not dependence on foreign oil, dependence on foreign clean energy hardware. That does not make solar a mistake. In fact, it proves the opposite. Solar has become so important that the factory base behind it now matters strategically. When a technology becomes central to national power, the supply chain behind it becomes part of the power equation. So the lesson is not that cheap Chinese solar is useless. The lesson is that cheap solar comes with strategic consequences when production is concentrated. China's scale helped the world deploy clean energy faster, but it also gave China leverage over the industrial foundation of that deployment. America now has to decide what kind of role it wants to play. It can be a buyer, it can be an installer, it can be a project developer, or it can be a builder of the industrial base itself. Those are very different positions. A buyer depends on price. An installer depends on supply. A developer depends on financing and interconnection. But a manufacturer controls part of the system. And in the next energy era, controlling part of the system may be the difference between participation and power. The United States still has major advantages. Huge energy demand, capital, engineering talent, research labs, land, world-class companies, and growing political recognition that clean energy supply chains matter. But China has scale, speed, coordination, and a long head start. That is why this race will not be won by slogans. It will be won by execution. Factories that produce, supply chains that function, workers who are trained, projects that connect to the grid, policies stable enough for industry to trust, and costs that can compete in the real market. Because the energy transition is not only a story about replacing fossil fuels with renewables, it is a story about rebuilding the industrial foundation of electricity. The solar panel on a field in Texas may look like a simple piece of clean energy hardware, But behind it is a global contest over factories, supply chains, technology, and leverage. China understood that early. It built the machine behind the boom. America is now trying to catch up. And the outcome will shape more than solar. It will shape batteries, grid equipment, industrial jobs, alliances, energy security, and who holds power in the clean energy economy of the next decade. China's solar boom did not just expose a gap in American manufacturing, it exposed a deeper question about the future. Will the United States simply consume the technologies of the energy transition, or will it build the industrial base that gives those technologies strategic power? Because in the next energy race, installing the future is not enough. The real power belongs to the countries that can build it.